Kia ora Year 12. This is the first video I'm going to do on the binomial theorem used for negative and fractional powers. So in class we looked at where the coefficients came from, and we just got up to using those coefficients to do our first expansion. This example is another really simple one, and we're going to have to look at going up to the term in x to the power of 4 and then finding the values of x for which the expansion is valid. So remember, I can write out this expression as an infinite series, and it goes like this. Last year, when you looked at this, we did this for positive powers of n that were integers, in other words, natural numbers. So this year we extend that idea to negative powers and fractional powers, and that means that instead of stopping when the coefficients hit 0, we have an infinite series. I need to go up to the term in x to the power of 4, so it's going to go like this. Now it's a bit of a pain that the screen isn't bigger, because I'd like you to write it out across the width of your page in your maths book. So let's have a wee look at that. Okay, so that's looking good. Now you need to know that, obviously, for the exam. So you need to get used to the patterns that you're seeing here. The next thing we're going to do is to look at our expression here and rewrite it, because it's got to be in the right form. So it's equal to 1 plus x to the negative 2. So we want to check a couple of things. First, that we've got an n value, so our n is going to be negative 2. And second, we need to have it in this 1 plus x form. In this case, it's our first example, so I've given you that straight off. Now we're ready to go. So 1 plus x to the negative 2 is going to equal 1 plus negative 2 times x plus negative 2 times negative 3 over 2 factorial x squared plus negative 2 times negative 3 times negative 4 over 3 factorial x cubed. And the last one here, because we're asked to go to the term in x to the power of 4, is negative 2 times negative 3 times negative 4 times negative 5 x to the power of 4 divided by 4 factorial. Now I've just done that to make you do one like that. Typically we're interested in a quadratic approximation or maybe a cubic approximation, but it's good to get in the habit of writing out all of those coefficients. So now figure out what those are, and on the next slide I'm going to simplify it all and then look at where it's valid. But you should spot quite a nice pattern in there once you start knocking out common factors. Okay, so now we're ready to clean this up. Here's what you should have got. Well, we're going to have 1 minus 2x. Right, checking your pattern with your negatives, you've got negative times a negative, so it's going to be a plus. And 2 over 2 factorial just leaves me with the 3 plus 3x squared. You might be starting to see a pattern, hopefully. Now, 3 factorial is 3 times 2. Up here, what have I got? 3 times 2. So it's going to be a negative, because I've got negative, negative, negative. So it's going to be minus 4x cubed. Right, the next term, negative, 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 negative. So it's going to be positive, plus, and again, 4 factorial. In this case, is exactly the same as 2 times 3 times 4, so they go. So what do I have? I've got plus x, 5x to the power of 4, dot, dot, dot. So that's my infinite series. So when I want the quartic approximation to the term in x to the power of 4, I'm going to write this is roughly equal to 1 minus 2x plus 3x squared minus 4x cubed plus 5x to the power of 4. And as I said, you won't usually have to go out that far. It'll usually be a quadratic approximation. And then the last thing we're going to do is to say where it's valid, and it's going to be valid when x is less than 1. Right, the reason that the validity condition is so easy here is because I'm in this form, 1 plus x to the power of negative 2. we're going to see this change when we start having x be slightly different things. Thanks for watching. I'm going to try and do a few more examples over the weekend, and they will gradually step up.